Hey everyone, wanted to start out our unit on states of water with a little experiment, so to speak. So what we have here are two liquids, liquid A and liquid B, liquid A and liquid B. Now if you had to guess, what would you think that both of these liquids are? There's liquid A and liquid B. Now looking at some of the properties, of course both of these are a liquid. You can see that both of them are liquids. Okay, both of them are clear. Okay, if you had to guess, what type of liquid would you think that these are? All right. So what we're going to do is we're going to take these two liquids and we're going to place them in the freezer for 24 hours and see what happens. All right, so we're going to go ahead and pause the video and put them in the freezer for 24 hours. So this is the unit on states of water. In this picture, you see three different states of water, believe it or not. You see the water, of course. You see ice. And then in the clouds, you see water vapor. So three different forms of water, three different states of water. Here's some vocabulary to start us out. Water, of course, is a liquid that all living things need to survive. Now, while the definition includes the word liquid, we all know that water can take three forms, and that's both liquid, gas, and solid. Melting point is the temperature at which a substance changes states from a solid to a liquid. Boiling point, the temperature at which a substance changes states from a liquid to a gas. And freezing point is the temperature at which a substance changes from a liquid to a solid. Celsius is the scale on a thermometer based on the water boiling point of 100 degrees Celsius and freezing at 0 degrees Celsius. Points and named after Anders Celsius, a Swedish astronomer. Now there is another scale that we are more familiar with here in the United States, and that's called the Fahrenheit scale. Physical state is the classification of matter as a solid, liquid, or gas. So when you hear somebody say, what physical state is it in? The answer would be either a solid, a liquid, or a gas. And then, of course, evaporation. Evaporation is water changing from a liquid to a gas. So that's at the point where it's heated to the point where it's changing from a liquid. It's in liquid form. It's boiling and it's heating those molecules up. Those molecules keep getting more and more excited, and eventually they start to travel into the air and it becomes a gas. And then, of course, condensation. Condensation is water changing from vapor or gas to a liquid. Now, that's we see that most often when we have a cup of water on a hot day, a cup of ice water on a hot day. It's that water that forms on the outside of the cup. What is meant by a state of water? Of course, we're all familiar with the state of Florida, but that's not exactly what we mean. Water is found in different physical forms or states and can be changed between these states. Water can change from a solid to a liquid. It can change from a liquid to a gas. Water can even change from a gas to a liquid. How exactly does water change between its different states? So these are the three states a liquid can be in. Of course, it can be in a gas, a liquid, and a solid. Now, when it goes from a gas to a liquid, we call that condensation. And when it goes from a liquid to gas, we call that evaporation. When it goes from a liquid to a solid, we call that freezing. And when it goes from a solid to a liquid, we call that melting. Now, if you notice, a gas cannot go directly to being a solid. It must go to liquid form first, okay? So you can't skip stages. Okay, you can't have a solid without it first changing into a liquid, and you can't have a gas with it. It can't be a solid and then go directly to a gas. When a substance warms up, it gains heat. What happens when it cools? So it's, as you see in this picture, you have the burner and it is heating the water in the container, okay? So as you remove that heat, when you remove that heat, obviously the bubbles will stop and then the temperature will go down. So it's losing heat. It's wanting to change to the heat of the room temperature. All right. So a cooling substance loses heat. It does not gain cold. Okay. So it doesn't. It doesn't gain cold. It's just losing the heat. The heat is the energy that is being provided to the liquid. And once you remove that energy, it will go back to the temperature of the room. Think about a tray of ice. You can fill it with water and put it in the freezer to make ice. As the water changes from a liquid to a solid, it loses heat. Okay, so it's not, the freezer is not adding energy. It is taking energy away. Okay? What tools can we use to measure temperature? So what tool can we use? And of course, losing or gaining heat causes the temperature of a substance to change. If water loses heat, the water's temperature goes down, it decreases. Similarly, if water gains heat, the water's temperature increases. Temperature is measured in units called degrees. Now, even if it's Celsius, it's degrees Celsius. If it's in Fahrenheit scale, it's degrees Fahrenheit. The most common tool for measuring temperature is a thermometer. Sometimes temperature is measured on the Fahrenheit scale. When you hear a weather report, you might hear the temperature will be 65 degrees Fahrenheit or 65 F. However, scientists can use the Celsius scale to measure and record the temperature of different substances. A temperature of 65 degrees Fahrenheit equals about 18 degrees Celsius. Now, the reason that Celsius scale is used on a scientific basis is because it's based off of a freezing temperature of 0 and a boiling temperature of 100. So it's a much easier scale to recognize where the level of energy is of the water or whatever it is that you're measuring. So that's why Celsius is more readily used in the scientific world than the Fahrenheit scale. At what temperature on the Celsius scale will water freeze or boil? At what temperature will ice melt? Like other substances, water needs to reach a certain temperature in order for its physical state to change. The temperature at which a substance changes from a liquid to a gas is called the boiling point. Now, all substances will have a boiling point, even metals, they will have a boiling point, and that's the point that they change. They begin to change from a solid into from a liquid into a gas. The temperature at which the substance changes from a liquid to solid is called its freezing point. The same thing. The gasoline in your car's engine, at some point that will freeze. Shampoo or any type of liquid will have a freezing point, and that's the temperature at which it freezes. All right, as you might have guessed, the temperature at which a substance changes from a solid to a liquid is called its melting point. Now, remember, it's not that the energy, as something is solid form and you add energy to it, it will eventually turn back into a liquid. So water boils when the temperature rises above 100 degrees Celsius, okay? So once it reaches 100 degrees, you'll start to see a physical change. You'll start to see the bubbles, and those bubbles are actually pockets of vapor or air, and they are what allows the vapor to rise into the air, okay? And then water freezes when the temperature drops below 0 degrees Celsius. Now, the temperature might go lower than 0 degrees Celsius, but it's at 0 degrees that water will change from a liquid to a solid. All right, let's try some experiments. All right, so here we are 24 hours later, and we have liquid A and not so liquid B. Seems as though liquid B has frozen. So we have our thermometer here. It's reading the air temperature as 73 degrees. And we stick our thermometer into liquid A, and it's saying it's exactly 0. But yet, it's still liquidy. Alright, and we'll allow the thermometer to cool off for a second. Alright, so now we're back to room temperature on the thermometer. And let's put it inside of liquid and we see that it's going down slowly. Can't really get it inside there because it's frozen. Alright, I've managed to find a little spot that I can stick it in there, and look at that. 32 degrees, which happens to be the freezing point of water. See if I can get it back down again. There we are. 32 degrees. And that was liquid B, and of course liquid A is much colder than the 32 degrees. So, why is that? Why do we have one liquid that has been sitting in the freezer for over 24 hours and it is completely liquidy, and then another liquid that sat in the freezer for the same time that is frozen solid? So in case you haven't guessed, liquid A is denatured alcohol. Liquid B is of course water, and we know from our reading that the freezing point of water is 32 degrees. Now, denatured alcohol will freeze eventually, but it must get much colder than 32 degrees. All right, so now let's take a look at boiling water. Now we know that the process of boiling water requires heat, right? So we have our heat, have our pot of water, and if you notice, the little tiny bubbles that are forming, especially around the edges where the water is making contact with the metal surface of the pan. These bubbles are actually the water vapor being released into the air. So it comes much like you do if you go underwater in a pool and you breathe out, your air that you're expelling comes out as bubbles. So this water vapor is trapped in a bubble and it's trying to escape. As the water heats, the molecules of the water are going more and more quickly, trying to get into the air as water vapor. Now, you can't really see, you can start to see a little bit the water vapor as it's rising above the surface. So if we were to take a temperature of our water vapor right now, and we see that the air temperature is about 74 degrees, and then when we stick it in there, it quickly rises 198, 99, 200 degrees, 201, and we see the bubbles are beginning to form more and more around the surface of the metal. See, the temperature is much higher around the surface where the metal is, because the heat is being applied directly to that surface, and then that heat is being transferred to the water. Okay, we see that the water, again, the temperature is 206, 207 degrees, and we begin to see, well, it's hard to see, but the water vapor is beginning to rise. Now the bubbles are forming, they're larger, they're much larger, so the liquid is getting more and more excited. The molecules in the water are more and more excited, and they're wanting to escape more and more, so they're forming larger bubbles. And now we see it's in full boiling mode. Now, what that really is, it's not a change in the water, it's the vapor wanting to escape and rise into the air. Now over here we have another little experiment. Now if I put my thermometer inside, you will see that the water temperature is about 212 degrees, and it is fully boiling, rolling boiling. But now I have a thermometer set up here a few inches above the boiling water, and we see that the temperature hasn't even reached 150 degrees yet. Now the reason for that is that, yes, the water vapor is escaping into the air, but even after traveling just a little, a few inches like that, it's still cooling as it rises. That excited air is bouncing off the sides of the pot, it's circulating inside the pot, and it's cooling as it rises. So we have a temperature of 212 degrees here inside the water, but yet it is barely at 150 degrees, a couple inches above it. So that's showing you that even though as the water vapor is rising out of the pot, it is still cooling. And by the time it gets this far above, I am able to put my hand on top. While it's warm, it's not hot. So that water vapor is wanting to cool. Okay. All right, let's go ahead and review. So water, it comes in 3 different states: solid, liquid, and gas. Water, it can go from a liquid to a solid or a liquid to a gas, but it cannot go from a gas to a solid. Water vapor is formed when the water molecules are superheated, become super excited, need to escape, and they rise out of the water. Ice is formed when the heat energy is removed. Remember, cold energy, there is no such thing as cold energy. You don't add cold energy to the water. You are removing the heat energy. And that's what makes it go from a vapor to a liquid, and then a liquid to a solid. Freezing temperature is the point at which liquid freezes. The boiling point is the point at which a liquid changes to a gas, and the melting point is when a solid becomes a liquid. All right, thanks for watching.